you're starting now. You're coming.
Please let's kindly rise to receive the members of convocation. Thank you very much. Please resume your seats. Madam Vice-Chancellor, Pro-Vice-Chancellors, Registrar, Provost, Deans, Directors, our distinguished Professor and Lecturer, members of convocation, the clergy, Togbuyo, invited guests, staff and students, our friends from the media, distinguished ladies and gentlemen, good evening to you all. Good evening to you all. It gladdens our hearts to welcome you all to the Great Hall of the University of Ghana. The University of Ghana remains dedicated to research excellence in line with its second strategic priority, impactful research. Therefore, we are happy to have you join us to celebrate our professor, Professor Nicholas Tete Kwaku Dzifa Dayie, a professor of medical microbiology at the University of Ghana Medical School and coordinator of the International Programs Office at the College of Health Sciences. This evening, Prof. Dayie delivers the second of the inaugural lectures scheduled for the 2025-2026 academic year, and he's going to address the topic, When Microbes Speak and Data Appear Inconsistent, Are We Witnessing Falsehood or Truth? I take the topic again. When microbes speak and data appear inconsistent, are we witnessing falsehood or truth? I invite you all to listen to him with rapt attention as he unpacks this topic. With a round of applause, distinguished ladies and gentlemen, please join me to welcome our registrar, Mrs. Emilia J. Mensah, to deliver welcome remarks and introduce the chairperson for this evening's gathering.
Thank you very much, Director of Public Affairs. Vice-Chancellor, Pro-Vice-Chancellors and other officials of the University of Ghana, members of convocation, students, distinguished ladies and gentlemen, a very good evening to you all. Give the Director of Public Affairs a better response. Good evening to you all. Thank you. I'd also like to welcome you to the Great Hall, and I also acknowledge all of those joining us online for this evening's inaugural lecture. We are delighted that you're all able to join us for the lecture, which is to be delivered by Professor Kwaku Tete Nicholas Dayie of the Department of Medical Microbiology, University of Ghana Medical School. Inaugural lectures are a significant tradition and part of the university's annual calendar, and every academic who rises to the rank of professor is expected to deliver an inaugural lecture. This offers the university the opportunity to recognize and celebrate the academic achievements of its faculty, and also enables professors to share their research with colleagues within and outside the university, and to celebrate this important milestone with family and friends. I am privileged to introduce the chairperson for today's inaugural lecture. Our chairperson is Professor Appiah Amfo, the first female Vice-Chancellor of the University of Ghana. She is a professor of linguistics, an accomplished administrator, and brings over 2 decades of experience in the higher education sector. Within the University of Ghana, she has held several key leadership positions before becoming Vice-Chancellor, including being the Pro-Vice-Chancellor for Academic and Student Affairs, the founding Dean of the School of Languages, and head of the Department of Linguistics. As Vice-Chancellor, she's championing the integration of technology across the university's operations while ensuring that the university's people remain at the heart of its mission. Professor Amfo has received numerous accolades for her contributions to education, leadership, and the empowerment of women. She's chair of the Council of the Association of Commonwealth Universities, Vice Chair of the Worldwide Universities Network Partnership Board, and the Association of African Universities Ambassador for Gender Equity and Social Inclusion. She's the founding president of the African Humanities Association and president of the International Federation for Modern Languages and Literatures. Additionally, she serves as vice chair on the boards of the African Research Universities Alliance and the Worldwide Universities Network. She's a fellow of the Ghana Academy of Arts and Sciences and an active member of several esteemed academic and professional organizations. Ladies and gentlemen, please join me to welcome Professor Appiah Amfo, Vice-Chancellor of the University and Chairperson for this evening's lecture.
Thank you, Madam Registrar, Pro-Vice-Chancellors, Registrar, Provosts, Deans, Directors, and Heads of Departments, our distinguished lecturer, Professor Nicholas Tete Kwaku Dzifa Dayie, faculty, staff, and members of convocation, past and present senior officers of the university, alumni and students, family, friends, and associates of the lecturer, representatives from the health sector, esteemed traditional rulers, eminent clergy, friends from the media, our students from the second cycle institutions, invited guests, distinguished ladies and gentlemen. Through resistance patterns, the real question is whether our systems are hearing them accurately. That is an important scientific and policy question because the credibility of laboratory results shapes treatment decisions, informs national surveillance, and guides public health action. The objectives of this lecture are timely as well as significant. First, it seeks to deepen our understanding of the biological realities of resistance and the methodological factors that can distort how resistance is detected, reported, and interpreted. Second, it draws attention to the importance of harmonized procedures, quality assurance, interpretive standards, and strong governance systems in producing reliable antimicrobial resistance data. Third, it challenges us to distinguish true epidemiological change from weaknesses in the systems used to measure it, so that the evidence we rely on for clinical care and policy is sound and trustworthy. This is not merely an academic exercise, it's a call to action. In a context where resistance threatens effective treatment options and places increasing pressure on health systems, reliable AMR surveillance is essential for better diagnosis, safer therapy, stronger laboratory services, and more responsive health policy. The lecture therefore contributes directly to healthcare improvement in Ghana by strengthening the scientific basis for antimicrobic use, laboratory practice, and surveillance systems. It also has wider relevance for the sub-region and beyond, especially in settings where healthcare systems face similar challenges of limited laboratory capacity, data inconsistency, and the need for sustainable surveillance architecture. At the University of Ghana, we are committed to scholarship that does not remain within the walls of academia, but one that speaks to national development and global well-being. This inaugural lecture embodies that commitment. It also aligns directly with our strategic priority on impactful research, which highlights interdisciplinary and collaborative research that addresses the most pressing issues of our time. Ladies and gentlemen, it is now my singular honor to introduce our distinguished lecturer for today's inaugural lecture. Professor Nicholas Tete Kwaku Dzifa Dayie is a professor of medical microbiology at the University of Ghana Medical School in the College of Health Sciences. His scholarly work covers antimicrobial resistance research, laboratory systems strengthening, and the development of surveillance architecture that supports evidence-based clinical practice and informs public health decision-making. For nearly 2 decades, his academic contributions have evolved from pathogen-specific epidemiology to the strengthening of national health systems designed to detect, interpret, and govern antimicrobial resistance data with scientific integrity. Professor Dayie attended Bishop Herman College, Pando, after his basic education at Tete. He later enrolled at the University of Cape Coast, where he pursued a Bachelor of Science program in agriculture. Following the completion of his first degree, Professor Dayie applied to pursue postgraduate studies in agriculture at the University of Ghana. During the admissions process, however, he received an unexpected invitation to attend an interview at the Department of Medical Microbiology, University of Ghana Medical School, and was subsequently admitted to pursue graduate studies in medical microbiology. This unforeseen turn in his academic journey would later shape his lifelong commitment with infectious diseases and antimicrobial resistance research. It was during this stage of his training that he came to appreciate a guiding principle that laboratory evidence must accurately reflect the biological characteristics of bacterial pathogens to inform effective patient care and responsible antimicrobial stewardship. Following the completion of his MPhil degree, He joined the Department of Medical Microbiology at the University of Ghana Medical School as an assistant lecturer, marking the beginning of his academic journey at the University of Ghana. During these formative years of his academic career, he was actively engaged in teaching medical microbiology to medical students and contributing to laboratory-based investigations in clinical bacteriology and antimicrobial susceptibility testing. At the same time, he was a co-investigator on the Danida-funded antibiotic drug use, monitoring and evaluation of resistance (ADMER) project in Ghana, which ran from 2010 to 2015. As part of the core research team, he contributed to the development of the project proposal and the implementation of studies examining antimicrobial use and antimicrobial resistance patterns in Ghana. Within the framework of this project, he was awarded a doctoral scholarship to the University of Copenhagen, Denmark, where he pursued PhD studies in molecular bacteriology and infection. His doctoral research focused on the molecular epidemiology and antimicrobial resistance mechanism of Streptococcus pneumoniae and Enterococcus species under the supervision of 5 professors. This experience provided him with advanced experience in bacterial genomics, antimicrobial resistance mechanisms, and pathogen adaptation, while strengthening his ability to connect molecular bacteriology with the operational realities of diagnostic laboratories and healthcare delivery. Professor Dayie was promoted to senior lecturer in 2015, associate professor in 2021, and professor in 2025. Between 2018 and 2021, Professor Dayie was selected as the Fleming Fellow under the Fleming Fellowship Program administered through the London School of Hygiene and Tropical Medicine. In 2025, he was promoted to the rank of Professor of Medical Microbiology at the University of Ghana, marking the culmination of nearly 2 decades of progressive academic leadership within the Department of Medical Microbiology. Professor Dayie has served as a technical lead to national proficiency testing initiatives in clinical bacteriology laboratories, strengthening interlaboratory comparability and improving confidence in antimicrobial susceptibility testing results across Ghana's laboratory network. He significantly contributed to the development of harmonized standard operating procedures across human, animal, and environmental sectors, and led the development of Ghana's integrated antimicrobial resistance, antimicrobial use, and antimicrobial consumption surveillance strategy under the FHI 360 supported EPIC Ghana Global Health Security Project funded by the United States Department of State. He serves as a member of the Surveillance Technical Working Group of the AMR Platform of Ghana. He is also a member of the AMR Multi-Stakeholder Partnership Platform, which is facilitated by FAO, UNEP, WHO, and WOAH, participating in global cooperation to address antimicrobial resistance. Professor Dayie has authored and co-authored more than 80 peer-reviewed scientific publications and has contributed to securing competitive research funding from Danida and successive Fleming Fund country grants, including Phase 1, Transition, and Phase 2, in partnership with the University of Ghana and AROM Institute, Ghana. He's also served as co-investigator on multiple National Institutes of Health research grants. Collectively, he has contributed to the successful acquisition and implementation of research and capacity building grants exceeding $12 million in support of antimicrobial resistance surveillance, infectious diseases research, and laboratory systems strengthening. Within the University of Ghana Medical School, Professor Dayie serves as Departmental Examinations Officer. He has served as Departmental Examinations Officer. He currently serves as Module Leader for the Infection and Immunity Module, Preclinical Program Coordinator for the Regular Medical Program, and Phase 1 Manager of the Graduate Entry Medical Program. Through his teaching and supervision, he has mentored and trained many undergraduate medical students and postgraduate students in medical microbiology, contributing to the development of the next generation of clinicians, researchers, and laboratory scientists. At the College of Health Sciences, he serves as the International Programs Coordinator. Beyond his responsibilities within the University of Ghana, Professor Dayie contributes to broader academic capacity building initiatives. He's been part of a consortium led by King's College London that developed a transnational curriculum for the award of postgraduate certificates in education, supporting cross-border capacity building in health professions education. Beyond academia, Professor Dayie has served as consultant to the American Society for Microbiology, the African Society for Laboratory Medicine, and the Fleming Fund and FHI 360. Through research, policy engagement, and academic leadership, and laboratory systems strengthening, Professor Dayie has worked to bridge molecular bacteriology with health systems architecture. This intellectual journey, from the study of bacterial pathogens to the strengthening of surveillance systems capable of detecting and interpreting antimicrobial resistance, forms the foundation of his inaugural lecture, which reflects on the scientific responsibility of ensuring that laboratory evidence accurately represents biological characteristics of bacterial pathogens. Professor Dayie is a son of Professor Grace Yawo Gadegui, formerly of University of Education, Winneba. He's married to Dr. Alberta Dzifa Dayie, lecturer in chemistry at the University of Cape Coast, and together they are blessed with 4 children, Eliagbe, Elenam, Aram, and Yaira. It is my pleasure now to invite us to listen with key interest as Professor Nicholas Dayie delivers on this important topic, when microbes speak and data appear inconsistent. Are we witnessing truth or falsehood? I trust that the insights shared today will enrich our understanding, sharpen our practice, and contribute meaningfully to the fight against antimicrobial resistance in Ghana, in Africa, and beyond. Ladies and gentlemen, our inaugural lecturer for today, Professor Nicholas Dayie.
What's up? I couldn't know any antini. And Mamma Kwaba. I am Professor Appiah Amfo. I see you point down for no Bapa Monicasa. Adia Sambia Samano Samamaka Nasumedi in kind ɛde ayɛyie ɛne naaseɛ ama mawu tɔgɔrisa mawu sɔgɔrisa adumo na dumo ntini ate aseɛ aseda wure yɛda wasio mi yankopɔn yɛda wasio mi wure aseda o asuapɔn ɛwɔ nhyehyɛeɛ bi ansa na yɛde edin professor ɛbɛto wo soɔ no a ɛwɔ ho amamene agye sɛ wobɛdi nkan ɛyɛ abadwa mu kasa kyerɛ ɛno ne yɛfrɛ no inaugural lecture bɛma no anyamfoɔ bi na aduru no so a ɔkyerɛ apɔmuden ɔyɛ kyerɛkyerɛfoɔ wɔ suapɔn yi mu na ɛdin a yɛde frɛ no ɛne Professor Nicholas Tete Kwaku Dzifa Dayie bɛma no anyamfoɔ yi ɛberɛ asoso a wokasa ɛne asoma me sɛ memra na memɛfrɛfrɛ wo sɛ nyankontom frɛ nsu anɔpa atutu Kwaku yɛ Prof ɛberɛ no aso o ɛberɛ no aso kasa o ɛberɛ no aso kasa nananom me ne nsa berɛ ɛberɛ no aso o kasa o kasa ɛyɛ wɔ wura ayɛ abɛta Dayie wɔn nso ɛyɛ kyerɛkyerɛfoɔ wɔyɛ okunini ɔbaa nuanyamfoɔ yi na ne kunu no ɛmɛ na kasa o kasa ayɛto nsa frɛ wo agya kasa asuafoɔ a wɔayɛ nyina twa yɛn ho ahyia ɛtia wo Ghana nyina ɛtia wo asuafoɔ a yɛwɔ a ɛtia wo abɛmfoɔ ɛberɛ no aso kasa o gara kasa o abɛmfoɔ kasa o kasa o
Distinguished Vice-Chancellor, Professor Nana Abba Appiah Amfo, former Vice-Chancellors of the University of Ghana, Pro-Vice-Chancellor, Academic and Student Affairs, Pro-Vice-Chancellor, Research, Innovation and Development, the Registrar of the University of Ghana, provosts, deans, directors, heads of departments, members of convocation, our revered chiefs and queen mothers, our eminent clergymen, our friends from the media, families, students, distinguished guests, ladies and gentlemen. Nicholas Dzifa Tete Kwaku Dayie is my name. And with a profound gratitude to God and a deep sense of humility, I introduce you to the topic, when microbes speak and data appear inconsistent, Are we witnessing falsehood or truth? When microbes speak and data appear inconsistent, are we witnessing falsehood or truth? One more time. When microbes speak and data appear inconsistent, are we witnessing falsehood or truth? Already, the narrative on my scientific journey has been given by our distinguished Vice-Chancellor. Therefore, I will proceed with the second item on the lecture outline. I'll go straight ahead to microbes, resistance, and the burden we face. I would also talk about understanding variability in antimicrobial resistance data. Then, of course, I will look at engineering truth in antimicrobial resistance surveillance. Then, of course, we shall look at Ghana's journey towards reliable and sustainable antimicrobial resistance surveillance. And then, of course, no one is ever made by himself or herself. So I would acknowledge those that have helped me as destiny helpers on the road to the top. In our environment, there are two types of living things. We have those that are big enough for the naked eye to see, and we call them macroorganisms. Then, of course, we have those that are too small for the naked eye to see, except with the help of a microscope, and we call them microbes or microorganisms. Those that are too small for the naked eye to see, we call them microbes or microorganisms. In the field, in that particular field, or we call the people who study the invisible creatures, we call them microbiologists. And the field that these organisms dwell, we call that field microbiology. In the field of microbiology, we have different types. We have bacteriology, which is the study of bacteria. We have mycology, which is the study of fungi. We have parasitology, which is the study of parasites. Then we have virology, which is the study of viruses. I am a bacteriologist, which means I study bacteria. Now, bacteria, there are two categories of them. We have those that we call commensals or normal flora. Then we have those that cause disease. We call them pathogens. The commensals or normal flora, they live together with our cells and help us in digestion and metabolism. They help to train our immune systems, and they also help us in the production of vitamins. And of course, when you attempt to close your eyes and say you are dead, they will also help to reduce your body to dust. So that's how beneficial commensals are to us. Then, of course, those that cause disease, we call them pathogens. And for this particular lecture, we shall focus our attention on pathogens. In ordinary language, you will call them germs. But in our field, we call them pathogens. Now, when the pathogens cause disease, we treat them with antimicrobial agents. And of course, if it is bacteria, Then it is antibacterial agents we use to treat the infections that they cause. Some of the antibacterial agents only retard the growth of the organisms. They don't kill them. And we call those antibacterial agents to be bacteriostatic. Bacteriostatic. Then we have another group that kills the bacteria that is causing the disease. That group, we say, those antibiotics or antibacterial agents, we call them to be bactericidal. Bactericidal. So bacteriostatic retards the growth of the organisms. Bactericidal kills the organisms. But along the line, bacteria have found a way of resisting the activities of the antibacterial agents. That demonstration of insensitivity to the antibacterial agents, we call it antimicrobial resistance. Antimicrobial resistance. And bacteria are able to resist the effect of antibacterial agents either through inherent characteristics that they possess, or they acquire resistant genes from their environment. They either resist the effect of the antibiotics by inherent characteristics that they possess, or they acquire resistant genes that make them to resist the activities of the antibiotics or the antibacterial agents. Such phenomenon is what we call antimicrobial resistance. Now, before we move further, I'll quickly have to define truth and falsehood in antimicrobial resistance, because the topic, if you mention truth, is comfortable. The moment you mention falsehood, it brings tension. And I want to remove the tension. Now, truth refers to, in this particular lecture, refers to genuine characteristics of the organisms expressed. Genuine characteristics of the organism expressed. Falsehood in this lecture does not connote dishonesty on the part of the laboratory worker. Falsehood does not connote dishonesty on the part of the laboratory worker. But falsehood in this lecture means distortion introduced by weak laboratory systems, poor diagnostics, inconsistent methods, and surveillance data that fail to accurately reflect what the microbes are truly saying. So you see, you should relax. Falsehood doesn't mean that you falsify figures in the lab and report to the doctor. Falsehood doesn't mean that you fabricate figures and report to the doctor. Falsehood here means that the system is not accurately capturing what the microbes are saying when you investigate them. That is falsehood. So I think that tension should be removed by now. Now let us look at the burden that antimicrobial resistance has caused in the whole world. Indeed, it has been said in 2019, studies have stated that 1.27 million deaths were directly attributable to bacteria antimicrobial resistance globally. 1.27 million deaths were directly attributable to bacteria antimicrobial resistance in 2019 alone. And again, 4.95 million deaths were associated with bacteria antimicrobial resistance globally in 2019. Now, there is a difference between attributable death and associated death. Attributable death here means that it is the organism's infection that is actually resulting in the death of the patient. That is to say, if we find an antibiotics that can kill that organism, the patient would have recovered from the disease. But associated death here means that there are other underlying conditions to which the bacteria takes advantage of and kill the patient. So even if you find antimicrobial agent that can kill the bacterium, the underlying conditions would have resulted in mortality. So that's the difference between the two. Now, based on these statistics, it has been projected that by 2050, 10 million people will lose their lives every year. And majority of the burden is actually in sub-Saharan Africa. Majority of the burden is in sub-Saharan Africa as compared to the developed nations. And again, AMR or antimicrobial resistance has economic cost. It has economic cost. In 2017 alone, it cost the world $300 billion. 2017 alone. Antibiotic resistance or antimicrobial resistance caused $300 billion loss to the global economy. And by 2050, it is projected that $100 trillion will be lost, leading to a reduction in 2 to 3% of the world GDP. That tells you how great or grave this problem of antibiotic resistance is. And evidence also suggests that by 2050, antimicrobial resistance will kill more than tetanus infection, will kill more than road traffic accident, will kill more than measles, will kill more than diarrhea diseases, will kill more than diabetes, more than cholera, and more than cancer. So AMR is considered a silent pandemic. So already we are experiencing a silent pandemic with respect to antibiotic resistance or antimicrobial resistance. What is the nature of the burden in Ghana? We've moved from the world, we want to look at it from the Ghanaian perspective. In 2019, 5,900 deaths were directly attributable to antimicrobial resistance in Ghana. 5,900 people. That is more than all the people in this great hall died due to infections caused by antimicrobial resistance. And again, within the same year, 25,300 deaths were associated with antimicrobial resistance in Ghana. And studies have shown that out of 204 countries, Ghana was ranked 35th in 2021 for deaths linked to antimicrobial resistance. Ghana was ranked 35th out of 204 relating to AMR deaths. How does AMR show itself in the infections that cause this disease? What are the syndromes that they are involved in? Indeed, the leading infectious syndromes contributing to mortality in Ghana are bloodstream infections, that is, bacteria infecting the blood. The second one is lower respiratory tract infections. The third one is tuberculosis. The fourth one is diarrhea diseases. And the fifth one is meningitis. This means that strengthening blood culture systems, respiratory diagnostics, cerebrospinal fluid analysis, and stool culture should be a national priority. It should be a national priority. The key message here is that the infections contributing most to mortality are also the infections for which strong microbiology systems are most needed. Beyond the syndromes themselves, which pathogens are responsible for the bloodstream infections? Which pathogens are responsible for the lower respiratory tract infections? Which pathogens are responsible for tuberculosis? And which pathogens are responsible for the diarrhea disease and meningitis? We've realized that just a few of the pathogens are involved, and antimicrobial resistance is not equally distributed across all bacteria. It's just a few number of them that are responsible for the large number of deaths in Ghana. And these ones are Klebsiella pneumoniae, Acinetobacter baumannii, Escherichia coli, Streptococcus pneumoniae, Staphylococcus aureus, and Pseudomonas aeruginosa. These are the few organisms that are responsible for the deaths in Ghana. So it means that there is a need for proper identification of these few number of organisms, assuming that the laboratory misidentify just a few of these, it will affect our national estimate on AMR. That will affect our national estimate on AMR. However, the reliability of our estimates depends not only on the identification of the pathogens involved, but also in the strength of the laboratory network itself. That is to say, how strong are the diagnostics that are powering our surveillance? How strong are they? How strong are our diagnostics that are contributing to data generation in our surveillance? In 2016 to 2019, the Fleming Fund Global or Regional Program advanced some money to some scientists to conduct a very important study. They call the study Mapping Antimicrobial Resistance and Antimicrobial Use Partnership Study. And they looked at the laboratory network of Ghana and came up with the statistics that Ghana has 4,841 total microbiology laboratories. We have 4,841 laboratories. Out of this number, 93 have bacteriology testing capacity. That means only 93 have the ability to isolate bacteria, classify bacteria, identify bacteria, and generate antibiotic susceptibility test results. 93. That translates into 2% of our laboratories with this capability. So that tells you clearly that the diagnostic base that supports our surveillance system is weak. It's not robust enough. And therefore, national estimates may not represent the true national picture. That is what it means. Just 2% of our laboratories have the ability to isolate, classify, identify, perform antibiotic susceptibility testing. That tells us that our surveillance is resting on a limited diagnostic capacity. As I often emphasize, surveillance is not merely data collection, it is about truth. Without diagnostic truth, stewardship becomes guesswork. Without diagnostic truth, antibiotic stewardship becomes guesswork. Antibiotic stewardship asks that use antibiotics or antibacterial agents only when needed. How do you know you need antibiotics or antimicrobial agent? How do you know that? You get to know only through diagnostics. When the laboratory tests and tells you that the organism causing the disease is bacteria, then you can choose the right kind of antibiotics to treat the infection. So then, without diagnostic truth, stewardship actually becomes guesswork. Now, what are the drivers of antibiotic resistance in the world, or for that matter, in Ghana? What are the drivers? What are the things that drive it? In any geographical location, if you want to know the drivers of resistance, or when discussing it, you must discuss it within two frames of mind. The first one is, what are the factors that are influencing selection pressure? Selection pressure simply means that when organisms are exposed to antibiotics or antibacterial agents, when they are exposed to them, the weaker ones die. But the strong ones evolve, adapt, and become resistant to the drug. So the drug creates a selection pressure that automatically eliminates the weak ones, but gives opportunity for those that are strong enough to evolve, adapt, and become resistant to the drug. So we look at drivers of resistance from one angle, that is factors that influence selection pressure. The second one that we need to look at is the presence of high-risk clones of bacteria. I will explain the clones. A clone refers to a group of bacteria that come from the same parent cell. So for instance, my children come from me. They are a clone. They are genetically related. So in this one, we are saying a clone represents a group of bacteria that come from the same parent cell. So in antibiotic resistance, we have high-risk clones in a particular geographical location. Those high-risk clones are internationally recognized as highly resistant organisms. When you find them in a particular geographical location, you will know that when they multiply, antibiotic resistance will emerge because of their presence. Not necessarily because people abuse antibiotics, but just the mere presence of these clones will lead to drug resistance. So there are two things. First one is factors that influence selection pressure. And the second one is the presence of high-risk clones in a particular geographical location. So what are the factors that influence selection pressure? One of it is rapid infection and reinfection. It is when people are infected with a pathogen that they take antibiotics or they take antimicrobial agent. If you are not sick, you won't take antimicrobial agent. And use of the drug increases the chance of developing resistance. So one of the main factors that increase the use of antibiotics is what? Rapid infection and reinfection. The second one is self-medication. Self-medication. In fact, many of us, you will agree with me that sometimes when we are not feeling well, we don't go to the hospital. We just go to the drugstore or the pharmacy and buy drugs that we feel can resolve the problem that we are carrying. Self-medication is not a proper way of judicious use of antimicrobial agents. And sometimes also financial constraints. You go to the pharmacy, you say, okay, I don't have enough money. Can you sell just a little bit of this drug for me? Instead of taking the drug for 2 weeks, perhaps you buy it for 1 week. That incomplete way of taking antimicrobial agent would certainly drive antimicrobial resistance. Then the next one is high antibiotic consumption with less prescribing appropriateness. That is, you go to the hospital. The doctor does not request for a laboratory test to guide the selection of an antimicrobial before prescribing. They prescribe based on the syndromes that they see, and they believe that by those ones you will get it. So inappropriate prescription is also a factor that drives selection pressure that also leads to antibiotic resistance. Then the worst form of it is the fact that we use these agents in animal husbandry. Instead of maintaining hygiene in animal husbandry, we prefer to increase the number of animals in a manner that makes the environment unhygienic, and therefore we substitute the unhygienic condition with the administration of antibiotics. Sometimes also antibiotics are given in order to fatten animals. Such practices also lead to the development of antimicrobial resistance. Then we have the issue of lack of awareness. Not everybody is aware of how best to use antibiotics appropriately. So that lack of awareness may also lead others to take antibiotics ignorantly. As we'll see in a quote by Fleming that says, and I quote, "The time may come when penicillin can be bought by anyone in the shops. Then there is the danger that the ignorant man may easily underdose himself, and by exposing his microbes to non-lethal quantities of the drug, make them resistant." Fleming prophesied about this or predicted this in 1945 when he gained his Nobel Prize after discovering penicillin. He indicated that a time is coming that people will go to the shops. Then there's the danger that the ignorant man may easily underdose himself, and by exposing his microbes to non-lethal quantities of the drug, make them resistant. I wish to say to you that in our day, you don't actually need to be ignorant in order to get underdosing. I will explain that just in a jiffy. One of the situation that will lead to the fact that you are knowledgeable but still get underdosed drugs is exposure to substandard antibiotics. Exposure to substandard antibiotics. I will show you a study we've done very soon that shows that in 2015 and 2020, we conducted a study. One of my colleagues looked at drug quality, and I looked at the effect of exposure of that drug and what happens in the laboratory. Then, from the study my colleague did, he realized that out of 348 antibiotics shopped from licensed chemical or shopped from authorized sales point and non-authorized sales point, 348 of them, he realized that 66% of those antibiotics have active pharmaceutical ingredient in them less than 50. 66% had active pharmaceutical ingredient in them less than 50%, as compared to what has been stated on the labels. So if you are a doctor who is prescribing such kind of antibiotics, how can you ascertain that you are getting the right dosage? How can you ascertain that you are getting the right dosage? You may never get the right dosage. So microbes would then be exposed to non-lethal quantities of these drugs, and with time develop resistance. Therefore, poor quality of antibiotics and widespread use may together contribute to the emergence of resistance. Now, looking at the two studies that we did, he published his work in 2020. I was in a hurry because I needed my PhD, so I published mine in 2015. But the work was done at the same time. I took particular notice of the drug called Septrin, the common name Septrin. But the scientific name is trimethoprim sulfamethoxazole or cotrimazole. Septrin is a combination drug. So I wanted to find out whether Septrin actually is working. So I tested the main part of the drug, which is the one that has the antibacterial effect. I tested that in the lab, and I realized that I realized that to trimethoprim is almost 100%, the organisms were resistant to it almost 100% in both organisms collected from Accra and Tamale. Then I called my friend and I asked him, what was the performance of Septrin in the drug quality analysis? And he revealed the truth to me that trimethoprim was just 32% in terms of active ingredient in it. 32%. The actual percentage that it qualifies to be is 90% and above. But trimethoprim had active ingredient component of just 32%. That shows that exposure of the microbes to sub-inhibitory concentrations of the drug or substandard drug drive resistance in these organisms. And these drugs were drugs that were used mostly at the time. So then, I am still wondering why trimethoprim sulfamethoxazole is still on our books, why we are still using them. They don't have any good function. Another study in 2021 proved that cotrimazole, all the organisms were almost 100% resistant to it. So we need to look at that carefully. We need to look at the quality of antibiotics that we have in our pharmacies that are being sold. Now, when microbes, we've come to the main meat of the presentation. Now, when microbes become resistant to antibiotics or antibacterial agents, how do they communicate this resistance to us? Which means microbes speak. But when they speak, how do they speak? Do they speak in Chui? Do they speak in Ga? Do they speak in Dagbani? Do they speak in Fanti? Or do they speak in Ewe? They don't speak in any of our Ghanaian languages, neither do they speak in any of the international languages. Microbes speak only in signals. Microbes communicate through measurable resistance patterns. So, for instance, they speak in signals. We have systems developed to measure these signals and interpret these signals to mean whether the microbes are susceptible to the antibiotics or they are resistant to the antibiotics. So microbes speak in resistant signals, and the laboratory detect these signals and interpret these signals to mean that the microbes may be susceptible to the antibiotics, which means that particular antibiotics can be used to treat infections that those microbes are susceptible to. Now, for instance, extended spectrum beta-lactamase producing Escherichia coli, they signal resistance to third generation cephalosporins. Another one is carbapenem resistant Klebsiella pneumoniae, also resist the last resort of drugs we have. For instance, carbapenems, examples of them include meropenem. They are the last choice of drugs to use to treat any of your bacterial infections. The last choice of drug to use, carbapenems. Examples are meropenem, itapenem, and doripenem. These are examples of carbapenems, which are our precious drugs. We are not supposed to be abusing them, but we've realized that there are organisms that we have circulated in Ghana already that have developed resistance to them. Then we also have another group called the methicillin-resistant Staphylococcus aureus. They demonstrate resistance to methicillin. And once you're resistant to methicillin, you are also resistant to all other beta-lactam antibiotics. Those are other groups of antibiotics that work against the bacterium. Then we also have the fluoroquinolone-resistant salmonella that complicate treatment of invasive infections. So these resistant patterns are biological signals detected through antimicrobial susceptibility testing. So again, when microbes speak, they speak through signals, resistance signals. We develop a test called antibiotic susceptibility test, which we use to hear what they are saying accurately or not. So our system of gathering what the microbes are saying, that system is called the antibiotic susceptibility test. And this is the reason why clinical bacteriology remains central to patient care. Now, what do clinical bacteriologists do? They isolate bacteria from your samples. When you go to the hospital and you say that you have this disease or you have these symptoms, the doctor will take samples or will write that you should go to the lab, and then perhaps they will take your blood sample, they may take your stool sample, they may take your skin samples, okay? And when they take those samples in the lab, the clinical bacteriologists are supposed to isolate the organism that is causing those pains you are having, those stomach aches you are having. The clinical bacteriologist is supposed to isolate that organism. Then after isolating the organism, the clinical bacteriologist would have to identify that organism. That is not the end in order to justify what is happening to your stomach. But that clinical, or in your blood, that clinical bacteriologist will then perform the test we call the antibiotic susceptibility test. What is the essence of this test? The essence of performing the antibiotic susceptibility test is to determine which drugs that the organisms are susceptible to, which drugs the organisms are resistant to. Then he writes a report to the doctor and say that, okay, based on this disease that is happening to this patient, based on the sample we have taken, this is the organism we have isolated. These are the drugs that the organism is susceptible to. Therefore, you can make a selection among these drugs to treat the infection. Or that same clinical bacteriologist will indicate to the doctor that based on the test we've done, drug A, B, C, D, the organisms are resistant to it. Therefore, do not prescribe those drugs to the patient. That is the essence of this test. Now, I believe you would all love to go to the hospital, that the doctor will not just prescribe a drug for you, but will request that your treatment should be guided by laboratory investigation. Unfortunately, as I explained, Ghana has just a limited number of labs that have the capacity to perform these tests. And therefore, the clinician is handicapped. They have to make do with what they have. They have to make do with what they have. So, they isolate, identify the pathogen, they determine the antibiotic susceptibility, and then give the clinician the result. But what if, in the identification of the organism, they made a mistake, not negligently, but because they may not have certain reagents to perform some of the functions that will lead to the true identification of the organism. And then they perform antibiotic susceptibility test. And instead of reporting that the organism is resistant to this drug, they write the organism is susceptible to the drug. What happens to you? Would you ever get healed after the clinician has prescribed the drug? You may never get healed. It will lead to prolonged hospital stay. It will lead to a lot of man hours. And if you are the breadwinner of your family, you will lose money. If you lose money, you can imagine the number of people who will be losing money, who will not be going to work. That also affects the national GDP. So AMR can also lead to death. It can lead to complication. It can lead to long stay in the hospital, and it can also lead to what? Death. Now, based on this particular study, our study that has just been published, on this study, we isolated a very powerful organism at the Kolebu Teaching Hospital in a surgical ward. And this organism is called Acinetobacter baumannii. And this organism is one of the most feared organisms in the world because of its capacity to be resistant to most drugs that are available to us. We realize that we use genomic tools. Let me explain. When we say genome, a genome refers to the total genes that are present in an organism, the genome. So genomic studies means that we are looking at the total gene load of an organism. And genomics surveillance has a very important benefit because it reveals the secret of microbes in their chambers as they gather and decide what to do with your life in the future. Genomics are able to identify the secrets, details that they have in their chambers. And genomics is able to relate that to the scientist. And the scientist is able to know that in the future, these and that are what these organisms have planned, and those are the things they will execute. Based on that foresight or that foreknowledge, strategies can be put in place in order to contain the outbreak of those things that the microorganisms have planned. So we use genomic tools on the isolate we collected from Kolebu Teaching Hospital, and we identify a very unique clone. Remember clone? Clone is a group of organisms that come from the same parent cell. So we identify this clone called ST2, the ST2 clone. This ST2 clone has the following characteristics. It is the most successful global epidemic clone. It is frequently associated with hospital outbreaks, especially in intensive care units. It has a strong ability to survive on hospital surfaces and on equipment. That is the characteristic of this clone. What are some of the antimicrobial resistant profile of this ST2? It is commonly associated with extensive drug resistance. You can see that it's not just multi-drug resistant, but it is commonly associated with extensive drug resistance, which means that it is resistant to most of the classes of antibiotics that are available to treat infections. What that means is that the doctor is now restricted as to only few antibiotics available to him to make decisions on. Now, what are the clinical implications of this? This particular organism or clone causes ventilator-associated pneumonia, bloodstream infections, surgical site infections, catheter-associated infections, and it causes severe infections in critically ill and immunocompromised patients. So, ST2 is not just a resistant strain. It is a highly adapted hospital survivor with major outbreak potential and limited treatment options. What I'm trying to say is that we have a clone of bacteria that is circulating within Kolebu, especially the surgical ward, that is highly resistant to antibiotics. And it is a high-risk clone of international proportion. As if that is not enough, this particular clone has OXA23 gene, a gene that we call OXA23. The OXA23 is a carbapinamase gene, and it destroys carbapenem antibiotics such as meropenem, imipenem, and doripenem. And this is extremely serious because carbapenems are the last line of antibiotics we have. And here is the case: we have a clone that has the capacity, a gene, that makes it to be resistant to our last choice of drug. In addition to that, they have another gene called the New Delhi metallobeta-lactamase 1. That is the NDM1 gene. This gene actually makes the organism to be resistant to all carbapenems, that is one, resistant to all cephalosporins, resistant to penicillins, and many beta-lactams. It often leaves only very limited treatment options. We have this organism carrying these genes. So they carry OXA23 and NDM1 genes. Now, these genes, interestingly, are carried on what we call mobile genetic elements. I know these terminologies are hard, but bear with me. I don't have simpler ways of describing them. They carry these genes on mobile genetic elements, which means that the genes can be passed on to other organisms in their environment. They carry these resistant genes on mobile genetic elements, and this means that these genes can be given to other organisms in that environment. And that is where I am afraid. I'm afraid because other organisms in our hospitals may have or acquire this gene. Remember from the beginning, I talked about the fact that microbes can become resistant based on inherent characteristics, and I also mentioned that they can acquire resistant genes and become resistant. So these genes that the ST2 clone is carrying circulating freely in our hospital can be shared with other pathogens in the environment, which makes it more dangerous. Now, when such high-risk clones emerge, an important scientific question follows. Are these resistant patterns reflecting true biological spread, or are inconsistencies in our systems affecting what we see? Are these genes reflecting true biological spread, or are inconsistencies in our systems affecting what we see? This brings me to the broader challenge of understanding why antimicrobial resistant data sometimes appear inconsistent. Now, resistant patterns reported by our laboratories may sometimes differ between laboratory to laboratory. They may also differ between one sector, let's say the human health sector, from animal health sector, from plant health sector, from the environment sector. Or they may even differ within the same laboratory over a period of time. So AMR may appear inconsistent within the same laboratory over a period of time. When that thing happens, the question is that we must ask an important scientific question. Are we observing genuine microbial evolution, that is, adaptation and changing within the population? Or are we observing variability, or that is, changes introduced by our measurement system? When you see these changes happening within the population of the organisms, where data inconsistency is occurring, are these genuine biological changes that are happening? Is it that the organism, based on selective pressure, they are evolving, they are adapting, they are becoming resistant to the drug, or the inconsistencies we are seeing are as a result of the system-related diagnostic problems? What are we seeing? That is the question. This distinction is critical because it determines how we interpret data, guide treatment, and shape national policy. In reality, variability can arise from several different sources, and these are classified into three categories. So whenever you see inconsistencies in antibiotic resistance data, three things may be happening. It could be that due to selection pressure from antimicrobial use, the organisms evolve, they adapt, or they acquire resistant genes and become resistant. If that is the case, then we are happy as scientists because we want to be able to capture the actual characteristics of the organism. That will help us in planning. Then the second means of introducing variability in AMR data is what we call system-related methodological weaknesses. System-related methodological weaknesses. Some of these could be that there could be deviations when the laboratory personnel picks a standard operating procedure to use. The standard operating procedure within one laboratory may not be the same standard operating procedure in another laboratory. And therefore, if two laboratories are using different standard operating procedures, definitely the result they generate can never be the same. It can never be the same. Another means of introducing variability in the AMR data could be poor quality of our reagents. Now, Laboratory A is sourcing their laboratory reagents from a particular company or a particular brand. Laboratory B is using a different brand altogether. Both of them cannot be giving the same or reproducible results. That is not true, and that is why we emphasize the need to harmonize standard operating procedures so that all laboratories use the same standard operating procedures, and we'll be sure that the result that we'll be getting will be reproducible and will be of high quality. So reagent quality or testing inconsistency can lead to system-related errors that the laboratory can churn out. Then we also have the weak laboratory quality measures. So in performing a laboratory test, there are various factors to consider. We have the pre-analytical factors, we have the analytical factors to consider, and we have the post-analytical factors. The pre-analytical factors look at sample collection, test selection, sample collection, and sample transportation. So within the pre-analytical phase, who are the people who work in this area? It's not only the laboratory worker. The clinicians are also involved because sometimes they also take samples. The laboratory personnel also take samples. Now, if the samples are not taken based on standardized procedure, definitely that can introduce a variability already. So no matter what you do in the lab, that pre-analytical error would affect the data that comes out of the laboratory. Then the second portion, which also introduces variability, is the testing phase itself in the lab. What kind of media is being used? What kind of consumables are being used? Are the equipment calibrated? Are they done? Are quality measures put in place to ensure that the test is working? Do we quality control all our tests all the time? Some labs do it, some don't do it. So those can introduce variability in the test result. Then the last one that can introduce variability in the test result is what we call the test condition dependent variability. This one is a biological sophistication. That is to say that the organism may possess the mechanism of resistance, but that mechanism of resistance, the gene, may not be expressed. It may not be expressed because perhaps the right laboratory test conditions have not been put in place. I'll take it again. This is called the test condition dependent expression variability. This one shows that the organism may possess the gene that may produce resistance to a drug, but the phenotypic expression of that gene may not happen. It may not happen because the necessary laboratory test conditions may not be provided. So this requires knowledge and skill. If the laboratory personnel misses this, he or she may end up producing data that is inaccurate for the clinician to use. For instance, I want to give an example. Assuming in the laboratory, you have an organism called Staphylococcus aureus, and this Staphylococcus aureus causes deep tissue infection, and then it has been isolated. And when isolated, antibiotic susceptibility test was done. And it shows that the organism is resistant to erythromycin, but is susceptible to clindamycin. Obviously, the laboratory maker who may not have the full knowledge of this result may quickly write to the clinician that, oh, this organism is susceptible to clindamycin. So, and if the doctor also does not have a full appreciation of this test, the doctor may also go ahead and prescribe clindamycin. But these are organisms that hide. This particular test that I'm describing, they hide their resistant mechanism. So there should be an instruction in the SOP or the standard operating procedure that when you find Staphylococcus aureus resistant to erythromycin but susceptible to clindamycin, go a step further and do another test which we call the D test. The D test will reveal that the organism has a hidden gene that will make the clindamycin not to be effective when taken. So even though you will find clindamycin susceptible and erythromycin resistant, you write to the clinician that do not use clindamycin, because when you use it, clindamycin therapy will fail along the line because the gene that will induce clindamycin resistance is hidden. The only way to unveil it is to go a notch higher, to perform that additional test. Unfortunately, not all our laboratories have the capacity and the knowledge to perform these tests, and therefore they may end up giving a result to a clinician which does not accurately resemble the actual communication of the pathogen. So based on these variabilities in data, generation in our laboratories, I have developed a framework, and this framework has got 4 pillars. The first pillar is called detection. Detection gives us the data. The second pillar is called validation. Validation gives us confidence in the data. The third pillar I call integration. Integration gives us the full picture of the antibiotic susceptibility test result from the various sectors that perform the test. So for instance, from human health, animal health, the environment sector, and plant health, they all perform one form of antibiotic susceptibility testing or not. And therefore, integration of this data gives us the national picture. Now, the fourth pillar I called governance. Governance will put this national picture into action. So detection gives us data, validation gives us confidence in the data, integration gives us the national picture, and then governance will put that data into use to influence national treatment guidelines or influence antibiotic stewardship policies. Now, beneath this pillars, we have what we call finance and sustainability. Because if you take detection, for instance, that is actually the scientific foundation. You need to grow the organisms. That is culturing of the organisms. It needs money. If you have to perform antibiotic susceptibility tests, it needs money to buy reagents, consumables, equipment. If you have to identify the organism further using molecular technologies, it requires money. So finance is important as far as detection is concerned. And again, under validation, if you have to review your standard operating procedures, you need to gather scientists together. They have to be in hotels to develop these guidelines. If you have to develop guidelines for quality assurance, you need to put people together. They all involve finance and sustainability. That applies to integration of the data as well at the national level. And governance can never do without finance. The finance is an important ingredient as far as this framework I am proposing is concerned. Finance underlines it all. And that is where we have our development partners. In Ghana, for instance, we had the Fleming Fund that came and assisted us from 2018 till 2026, and they checked out of Ghana on the 31st of March. So our development partners, they help us build systems, but of course the sustainability of the systems depends on the nation that they've built it for. Now, what is Ghana's journey towards reliable antimicrobial resistance surveillance? And what has been my role in this journey? What are my contributions in Ghana's journey towards reliable antimicrobial resistance surveillance? Ghana has developed integrated strategy for surveillance of antimicrobial resistance, use, and consumption, as well as residues, using a One Health approach. Ghana has also developed guidelines and protocols for antimicrobial resistance detection in the environmental sector. Ghana has also developed integrated standard operating procedures. Ghana has also developed laboratory quality manual and laboratory safety manual for antimicrobial resistance surveillance. In all this scheme of things, I have been privileged. I've been privileged, highly privileged, to contribute to the development of them. Some of them I led. Some of them I led, for instance, I am the lead, or I was the lead consultant, sponsored by the Department of State, United States of America, the EPIC Global Health Security Project, through the FHI 360 program. I was the lead consultant that developed the integrated strategy for surveillance of antimicrobial resistance, use, and consumption. And this is one in the whole world. The world will come to us and learn from us. Of course, I didn't do it alone. I did it together with the AMR platform of Ghana, very vibrant platform, the AMR platform of Ghana. And then within that platform, we have the Technical Working Group on Surveillance, headed by my own head of department, Professor Dzifa. Through them, we have developed this important document, which the world hasn't yet seen its kind. And then, in addition, we also developed proficiency testing scheme manual for the National Reference Laboratory for Antimicrobial Resistance and Surveillance in Ghana. My department and the University of Ghana Medical School and the University of Ghana has been given the title as the National Reference Laboratory on AMR in Ghana by the Ministry of Health. And we have developed a proficiency test, which I will tell you about very shortly. We've also developed training curriculum and manual for laboratory personnel on antimicrobial susceptibility testing in accordance to the CLSI standards. So from time to time, through the Aurum Institute Ghana and through the Fleming Fund, we have this curriculum developed, and we move from laboratory to laboratory to train them so that the data that will come from them will be of high quality. Then Ghana also developed a surveillance system, a very unique one, that when data comes from the laboratories that are in the district levels, all are aggregated at the national level. So at the click of a button, you can analyze this data. So Ghana has been making tremendous effort in order to contain antimicrobial resistance. The only thing is that the pace is very, very slow because our sector, the AMR sector, we need resources to be able to meet often. We need resources to be able to go to sites in order to train. I'm using this platform to advocate that if there is any donor who is willing to help the Ministry of Health to get this association ongoing to do its work, please come to our aid. Come to our aid. We can do something much greater than what we have done. Then, proficiency testing is actually an external quality assurance mechanism that evaluates laboratory performance. So therefore, participating laboratories receive standardized samples, perform identification and antibiotic susceptibility tests, and submit their results for independent evaluation. The purpose of doing the proficiency testing is not punitive. Rather, it is to identify variability, guide corrective actions, and strengthen confidence in laboratory performance. I should say that my department, again, together with the National Public Health Reference Lab, performed proficiency testing for all the laboratories that are under the Fleming Fund. So we test 20 laboratories, we send samples to them. That covers those in the environmental sector, animal health sector, and human health sector. Interestingly, the first proficiency testing we conducted, 4 out of the 6 major human laboratories did not make the mark of 80% pass mark. They didn't make it. 4 didn't make it. 4, which means only 2 made it. Now the point is this. From the perspective of a proficiency testing operator, this is not a national failure. Neither is it a demonstration of incompetence on the part of the laboratory worker. But to me, this is a diagnosis of a system that requires strengthening. And therefore, from these particular proficiency testing results, we provided inputs that help the laboratories to do investigation to see where they failed. And they found it, and they trained themselves. And therefore, subsequent PTs that we'll be doing, it is my expectation that they will perform and be at par with the 2 that passed. Remember, the passing is actually 80%. That is the pass mark, 80%. In addition to what the Ministry of Health, through the National Antimicrobial Resistance Platform, developed in terms of the software they've developed to capture data, I, together with another colleague, co-founded and developed a software that can help in handling data from our PT program. Because till now, we don't have any specific software for that. So looking at the challenge that is at stake, we came together and developed this software. Now, this software works. Whether you have internet or you don't have internet, the laboratory can enter the data wherever they are, either on the farm, in the environment sector, or in the hospital laboratory. They can enter the data. Once they are connected to internet, the software will automatically extract the data, analyze it, make the report available, and provide feedback. That hastens the process of providing feedback to our laboratories. What we want to do is to first patent this software, then we can make it available to Ghana and to the rest of the world. Now, beyond this lecture, What Ghana must do next to move from progress to sustainability? What should we do next as a country to move from progress to sustainability? Recall that the Fleming Fund who sustained or who funded our activities was from 2018 to 2026. They've checked out. What happens to the legacy that they've left behind? My advice or my suggestions are, we need to consolidate what the Fleming Fund and other donors have built from 2018 till date. We also need to expand our bacteriology capacity beyond the current limited laboratory network. We need to strengthen national proficiency testing and laboratory quality systems. That is my fear, because we have just tested and we realized that 4 out of 6 have not performed. How do we sustain this proficiency testing that we've established? We need help. Ghana must sustain AMR surveillance system beyond donor funding. We can't continue to put our health in the pocket of donors, because the day they decided to be angry with you, they will take your health away. So it's important that we find the resources to sustain the systems that we have built. Strengthen One Health integration across human, animal, plant, and environment sectors. We need to invest in training the next generation of clinical bacteriologists and antimicrobial resistance scientists. We need to build national financing mechanisms for surveillance sustainability. We also need to review and develop a new national action plan for antimicrobial resistance. The first one we had expired in 2021, and since then we haven't got the money to develop the next one. The Fleming Fund helped us to do the situational analysis, but since then we do not have the funding to continue to develop the next, or the National Action Plan 2. We haven't yet done that. So, are we witnessing falsehood or truth? When you appear before the doctor, and the doctor would have to treat you, and the test result comes from the laboratory, how much confidence do you have in the report? Are we truly witnessing falsehood, or we are witnessing truth? The thing is, we may be witnessing genuine microbial evolution, adaptation, and selection. We may also be witnessing structural distortion, which means that system-related methodological weaknesses can affect the result that the laboratory is churning out. In fact, it's one of the reasons why some doctors have refused to ask for laboratory tests again. When the data comes, the doctor does not trust the results, so he goes elsewhere to ask for the test to be done. I want to submit to you that those private labs that you trust so much, they may also not be doing the right things based on where we sit. So please, it is important we help develop what we have. We shouldn't kill the laboratories we have in our various hospitals. It's important we help develop them, strengthen them so that they work. So are we witnessing falsehood or truth? We may be witnessing falsehood. Falsehood not because the laboratory personnel is actually fabricating data, not because the laboratory personnel is falsifying data, but it is because the reagents, the consumables, the standards may not be available to such a person, or the person's knowledge or skill is not up to the task to get it done. One thing we found out in our training is this. We have few workers in the lab, and you have different benches. You have chemistry bench, you have bacteriology bench, you have other benches, and each of them is manned by different laboratory workers. Unknown to us initially, we thought that once you're on that bench, you stay on for long. So when we go and conduct training, we train the bacteriologists. Then after 3 months, that bacteriologist will move to the next bench. And the one we have not trained comes back to that bench. And what happens? They produce results that are not reproducible. So we recommended to the hospitals that we had visited that, look, it is important to maintain one person on one bench for a while. So that person receives the training and is able to train other people before he or she moves to the next bench. We think that is one way to help maintain quality in our testing capacities. Another thing is that the laboratories develop or they generate a lot of money in the hospitals. But whenever they need money to buy reagents, the hospitals will say, authorities will say, there is no money. But what is the money they've generated? So as part of our discussions with hospital management, we recommended that set aside some amount of the money that the laboratories generate, so that when they come requesting for those money to buy reagent, consumables, equipment, training, it will be made available to them. But the moment you tell them there is no money, there are no finances, but the people are generating the money, what happens to their confidence? They may be well trained, but they don't have the tools necessary to perform the task. They don't have the reagents necessary to perform the task. Fleming Fund spent £7.4 million for 8 years to resource these laboratories in terms of equipment, reagent, consumables, training. At the time they are providing these things, where is the money that they have made? Have they kept it aside so that when Fleming Fund or any other donor goes away, that money can be used to procure the reagents, consumables, the equipment? Or are we going to witness a situation that after just a year, all the investment is wasted? If it does happen, then we may not be called a serious country. We need to take our health seriously. Health should not be in the pocket of donors. It must be in our own pocket. We need to stand for that. That is a necessary thing to stand for. What must endure beyond this lecture? What should be my legacy behind after all this talk? My hope is not only to be remembered for detecting resistant organisms, but for insisting that antimicrobial resistance surveillance must be truthful. The laboratories must not merely produce data, but produce data that can be trusted. That stewardship must be guided by evidence, and evidence must be protected by quality, discipline, and integrity. That surveillance is not simply a technical activity. It is a scientific duty, a clinical responsibility, and a national obligation. Because when microbes speak, they do so truthfully. The responsibility rests with us to ensure that our systems hear them clearly, report them faithfully, and respond with wisdom. If that commitment endures beyond this lecture, then the work will have meaning beyond publications, will have meaning beyond projects, will have meaning beyond generations. Ladies and gentlemen, on this note, I thank you. Distinguished Chair, please kindly permit me a few minutes to acknowledge my mentors who brought me this far. Thank you. If you see any man or woman who tells you, I am made by myself, run away from such a man or a woman. No one is made by him or herself. You are made through the efforts of great minds. Indeed, I met a man who made me feel that it is worth it to carry on with research in life. I met him at University of Cape Coast. This man followed my life. Right after first degree, he supervised my work, and he followed me to University of Ghana when I was defending even my master's in the Department of Medical Microbiology. That man followed me till I went to University of Copenhagen to do my PhD, and he followed me till I became a senior lecturer, associate professor, and a professor. This man does not only look out for my academic excellence, but this man looks for my total good. He is in the person of Sir Professor Anthony Anampra. Professor Anampra gave me confidence in my career. He made me to see that it is worth it to sacrifice for others. Prof. Anampra was in Germany when he heard that I was going to give my inaugural lecture. He said, I am coming. I will come and listen to you. And after listening to you, I will go back. Prof. Anampra, I am so grateful and I'm indebted to you, and God bless you richly. The second person is Professor P.K. Texan. Professor P.K. Texan was formerly at University of Cape Coast. One of my favorite lecturers. He taught me anatomy and physiology of farm animals, and he taught me animal health. And he was then the head of department. Prof. Texan now works with University of Ghana. He was the former dean of the veterinary school of University of Ghana. These amazing people made tremendous impact on my life. Prof. Texan, many thanks. The next person is Professor Mercy Jemima Newman. Prof. Newman says, without her, perhaps I wouldn't have come to the medical school to do my medical microbiology. She stood in and said, I need this gentleman. I will take him on, and he will be my student. Prof. Mercy Newman taught me antimicrobial resistance. He supervised my MPhil and serves as a co-supervisor for my PhD in Copenhagen. Prof. Newman, wherever you are, know that you are highly appreciated. Indeed, she supervised the MPhil together with Professor Francis Tayman at University of Cape Coast and Mr. Prosper Adote. They supervised my MPhils, and I'm indebted to them for the great work that they've done in my life. Additionally, I had Professor Adiku, Reverend Professor Ayekumi, the former provost of the College of Health Sciences, Reverend Father Professor Kwamina Sego. They were so instrumental in shaping my thoughts in medical microbiology, and I remain grateful to them. And then Professor Anthony Andrew Ajay. This is the man who everybody needs Anthony Ajay in his or her life. He chased me up. Where are your applications for associate professor? If you don't bring it, I'm going to pray that you fall sick. That is the intensity of the chase. And he has been on me till today. The pressure he mounted on me is so phenomenal. Professor Anthony Ajay, you are a marvelous man. A marvelous man. Everybody needs him. And to my PhD supervisors, Professor Anders Dansgaard in Copenhagen, Professor Niels Frimodt, Professor Hans Christian, and Professor Emeritus Professor Mauna Bisgaard, and Prof. Newman. And I'm again saying I am grateful to you for the confidence and the skills you gave me. You are marvelous people. And then, of course, I had a wonderful friend in Göttingen Medical Center, Professor Uwe Gross, who is watching currently in Germany. He has been so good to me. Since we met in 2013, he has also been following my life till today. In fact, my inaugural lecture abstract, he read through and said, son, this is okay, go with it. Thank you, Prof. Uwe Gross. Then another important man is Professor, my mentor in the London School of Hygiene, Richard Stabler at the London School. Richard is a great guy, a great man. Richard gave me a lot of confidence in surveillance architecture design. He taught me a lot in genomics, and he taught me a lot in antimicrobial resistance and quality measures that we need to put in place. He did that together with Professor Martin Antonio at the Gambia. I am very grateful to them for what they've done for me. I'm almost there. I'm almost there. I got into the medical school as a lecturer under the deanship of Professor Aaron Lawson, Emeritus Professor Aaron Lawson. I don't know what he saw in me, what he saw in my application, and he was convinced that this gentleman need to stay in the Department of Medical Microbiology. So together with the panel, they made a good decision and took me on as a faculty. These are my career mentors. I've mentioned the ones up, but there's one person more that I need to mention, and he is Professor Eric Sampeni Donko. Prof. Eric Sampeni Donko is a great mentor. I call him my brother. He teaches me a lot, engages me often. We write proposals together. We conduct research together. Above all, we love the Lord together. So he's a great man, and I respect him greatly. Today, one other mentor, Professor Edwin Redu, called me and said, Nick, I desire to come and listen to you, but you see, I need to do a presentation elsewhere. Therefore, I am unable to come, but I want to pray for you. And he prayed for me, and he daily shares the word of God with me. That is how awesome this man is. And he told me, if ever you become a head of department, make sure at the beginning of each year, ask for the vision of every member of the department and take those written documents wherever you go and source for opportunities for them. This man is a great man. Then Professor Tete, and then another one called Professor Mark Tete. These two have Tete as their surnames. They are all full professors, but I can tell you, they have been great mentors to me in the medical school. They give me good advice at every point in time. Prof. Tete, I'm so grateful. Professor Mark Tete, I'm so grateful for all that you've done for me. And then one woman fished me out. She is Professor Margaret Latte. She was the one who gave me responsibility I never knew I could do, but eventually I got it done. She told me, Nick, I am a perfect woman. I want an excellent result just before COVID. I've spoken to your colleagues. They say you are the only one who can help with this job. But there is no money to the job. Are you willing to do it? I say yes. But I am an excellent woman. Can you deliver excellence? I said, you are just talking like my mother. Because I grew up from an excellent home. From a mother who taught me excellence in everything. And therefore, what she demanded, I put my heart to it. And by the grace of God, we got it done. Then the last two,
My current provost, Professor Alfred Ediyoso, a fantastic leader. Fantastic leader. He identifies opportunities and he also identifies talents. And then he aligns the talents with the opportunities and gives you a task to do. He is a wonderful man. I value the relationship we share and we'll keep it like that. Perhaps I work with the Jemimas. There is another Professor Jemima Anderson. The first one is Professor Jemima Newman. This one is Professor Jemima Anderson. The Dean of the International Programs Office, a great mentor, a person full of value, somebody who is honorable. She has been mentoring me ever since I became the International Programs Coordinator for the College of Health Sciences. Professor Jemima, wherever you are, I am deeply appreciative of what you've done for me. And this is the last. This is Emeritus Professor Joseph Achu Ayi within University of Ghana. Professor Achu Ayi is my grandfather, and the woman here is the sister called Florence Dede Ayi of blessed memory. My mother calls Professor Achu Ayi uncle, and therefore Professor Achu Ayi is my grandfather. And this is my mother, Professor Grace Yalgadagbi. Professor Achu Ayi had his inaugural lecture in this room, perhaps 26 years ago. My mother had hers 20 years ago. 20 years after, the son is also having his. I think this is a manifestation of generational grace, and we are grateful to Christ for what he has done for us. Distinguished Chair, I would like to say that I am very grateful to university leadership for this singular honor given to me to give this inaugural lecture. I am grateful to the Vice-Chancellor, Professor Nana Abba Appiah Amfo. I am grateful to the Pro-Vice-Chancellors, Academic and Student Affairs. I am grateful to the Pro-Vice-Chancellor, Research, Innovation and Development. I am equally grateful to the Registrar of the University. In fact, without her, it would be very difficult for us to have the brass band here because my request came in very late. But she was so considerate, her together with the Director of Public Affairs, University of Ghana. You have been so amazing to me ever since the information went out that I'll give my inaugural lecture. I am grateful to that department. I'm also grateful to the Provost of the College of Health Sciences and other sister colleges of the University of Ghana. I am grateful to the registrars of the respective colleges. I am grateful to the deans and directors under the College of Health Sciences. I am grateful to my head of department of microbiology. And of course, I appreciate greatly our research partners, national and international, my students. Without you, I don't think I would have done much. Thank you so much, my students. And I also want to thank my mentees and friends. I want to thank the Fleming Fund, the Aurum Institute, the FHI 360, and then I also want to thank the Institute of Computational Biology and Bioinformatics. And I am also grateful to the Director of CSIR Water Research Institute and his team. They are here today to support me. Finally, I want to say thank you to my wife. Beside every successful man, there is a woman. And my wife, Dr. Mrs. Alberta Dzifa Dayie, you proved to be a strong woman, and I appreciate you greatly. And I want to thank my children, Elagbe, Elinam, Eiram, and Yaira, and my mother and my father of blessed memory, Professor Grace Yalgadagbi, and Mr. Richard Rickett Dayie, my father, very great man who taught me work ethics. He told me, if you are sick, work. If you are healthy, work. Work defines you. That's what my father taught me. And I remain grateful to him wherever he is. And I am grateful to my brothers, Richard, Edward, and McAfee. Thank you so much for being there for me. And I thank my auntie. One of them calls Auntie Dzifa called Delight Servatok. When I was younger, she used to teach me arithmetic every day when I come back from school. Wherever you are, Auntie, I am so grateful to you. And I want to thank the Dayie family as well as the Aite Aminu family. Distinguished Chair, on this note, I am sincerely grateful to you. God bless you.
That was very wonderful. Let's continue to appreciate Prof. Dayie. Thank you very much, Prof. Dayie, for a lecture so full of lessons. We've learned a lot. We've learned that microbes speak in signals. I think that from today, you won't get up and pick your money and your own prescription to go and stand before an over-the-counter shop to buy your own medication. You seek assistance from our scientists, our doctors. He has provoked us to do more research. Let's appreciate him once more. Madam Vice-Chancellor, distinguished ladies and gentlemen, I am privileged to invite all of us to relax and take a performance by the Wind Ensemble from the dance department at the School of Performing Arts of this department. Please relax and listen to the Wind Ensemble. very much, Wind and Sam from the Department of Dance Studies at the School of Performing Arts. We are very grateful to you. Madam Chair, distinguished ladies and gentlemen, it's now time for presentations, but before we move on to that, I would like to acknowledge a few people. Professor Dayie already acknowledged a lot of the dignitaries that we have here, and so I'll concentrate on a few on my list. He has made my work easy. We have here with us Togbi Dr. Kisi Avwa Blachi IV, Dufia of Abutia, Anglo, with us. We also have Togbi Komlapwe, the Chief of Siame and Mankrado of Vegbodome, Afajato South, together with the Queen Mother, Mama Fofua the Queen Mother of the same area. We are privileged to also have Mama Adoshi III, Queen Mother of the Aite Aminu family. Thank you very much for joining us, Togbiyo Mama. I'll now move to Professor Mauto Avoke, former Vice-Chancellor of UEW. Do we have you here, please? Mr. Gabriel Ni Kome Adams, Executive Director of Ghana Libyan Arab Holdings Company Limited. As I earlier said, Prof. Dayie has acknowledged we have a number of former provosts of the College of Health Sciences here, whom he has already acknowledged. I'll now move to the presentations, and I believe that we are going to see some more of the invited guests through that. First on my list, as we earlier noted, Professor Dayie is from the Department of Microbiology at the University of Ghana Medical School, and so I invite the department together with the school to do their presentation. Department of Microbiology, Medical Microbiology, and the University of Ghana Medical School. While they are doing this, the International Programs Offices at UG, International Programs Office UG, and International Programs Office College of Health Sciences, kindly get ready to come with your gifts. International Programs Office at the main campus and at the College of Health Sciences. Please come up. I invite the postgraduate and undergraduate students of Prof. Dayie to get ready as well. Undergraduates and postgraduate students of Prof. Dayie, please get ready. While we are waiting for the students, let's have Mr. Gabriel Nikome Adams, Executive Director of GLACO. Can we then have CSIR, Water Research Institute, please? The next group should please mount the stage. Kindly come up and do your presentation. Ms. Elomgo, Executive Director, AgriSolve Ghana, please get ready. Ms. Elomgo. Miss Elon, yes, Elomgo, please come. Antimicrobial Resistance Platform of Ghana, are you here? While they are mounting the stage, shall we have the 1996 alumni of Bishop Herman College, led by the president, Mr. Christopher Ashiago. Please get ready. Bishop Herman, please get ready.
We'd like to sing our anthem for him. It's a request.
Bishop Herman Old Boys, please mount the stage now. Thank you very much. The College of Health Sciences should get ready. College of Health Sciences, where Prof. Dayie is coming from. We intentionally delayed their presentation to make a call to all the SHS students here to plan to come to the college. College of Health Sciences, please mount the stage. Led by their provost, Prof. Yosin, that's the College of Health Sciences. Mrs. Sefako, please can you mount the stage? Mrs. Sefako. While we are waiting for her, we will call our official beverage sponsor, Promasidor Ghana. Promasidor Ghana, please mount the stage and make your presentation. Promasidor Ghana Limited. Promasidor Ghana Limited, we are waiting for you. Mrs. Sefako, please mount the stage. Promasidor Ghana, please mount the stage. While Promasidor is coming, we will now move to the families of Professor Dayie. We will first of all invite his family led by Professor Grace Yao Gadawi, his mother, and his brothers to make their presentation before we invite the wife and the children. And now, last but not least, I invite Dr. Mrs. Alberta Dzifa Dayie and her children to make their presentations. Thank you all very much for your presentations. If for some reason we couldn't capture you, it's because of time. We have a desk at the forecourt. You can do your presentation there when we step out of here. For now, distinguished ladies and gentlemen, please join me to invite our chairperson to deliver her closing remarks.
Thank you very much, Director Public Affairs and Wind and Sound. Distinguished ladies and gentlemen, what an intellectually rich and important lecture that we have just experienced. Professor Dayie, on behalf of the University of Ghana, I thank you for a presentation which was scientifically rigorous and also philosophically provocative. I loved your contextual definitions of truth and falsehood. I thought it was only in philosophy lectures that I could get such definitions. Tonight, you took us into the invisible world, the world of pathogens, a world where microbes speak and where our systems are tested in the ability to hear truthfully. Thank you for the lessons on AMR. I now know the places to avoid. Indeed, the figures were scary, particularly the figures on mortality projections in sub-Saharan Africa. Even the data on Ghana, the number of deaths in a year caused by AMR. But I believe this is a reason why we have you and your colleagues working on such an important topic. After an expert like Professor Dayie has spoken, it would actually be suicidal for me to try to give a summary. And so, as I usually do, I'll just share with you some of the lessons that I picked from the lecture and from the lecturer himself. My first lesson this evening is that truth in science is not automatic. It must be engineered. Prof. Dayie showed us that antimicrobial resistance is not just a biological reality. It is also a measurement challenge. So between what microbes are doing and what we report lies a complex chain of systems, laboratory practices, quality assurance, standards, and even issues of governance. Now, if any part of this chain is weak, then truth becomes distorted. So this is where science and philosophy meet. So the question was posed, how strong are diagnostic systems? For without diagnostic truth, stewardship becomes guesswork. In other words, data does not simply exist, it is produced, and therefore that process of producing data must be protected. The second lesson for me is that systems matter as much as science. Professor Dayie's work demonstrates a critical shift from studying pathogens to strengthening the architecture of surveillance itself. Prof, you reminded us that without reliable systems, even the best science cannot translate to effective care or even sound policies. And that's a powerful lesson, and it's not a lesson for just microbiology, but it actually applies to all disciplines. Our diagnoses are as good as our laboratories, and our restorative health care is as good as our diagnosis. So it's important that we fix our laboratories, we invest in our laboratories as part of the attempt to strengthen our healthcare systems. Invest in equipment, in reagents, in training. So often when we are talking about improving our healthcare systems, there's very little heard about improving our laboratories. So perhaps we will use this platform to reach out to the Ghana Medical Trust Fund, aka Mahama Cares, that they need to take this into consideration as it seeks to strengthen our healthcare systems. Because indeed we need reliable, sustained local funding for our healthcare systems. We heard our lecturer, he said that our health should not be in the pocket of donors. The third lesson for me is that variability is not always error. It can actually be insight. So when data appear inconsistent, the instinct is often to dismiss it. But as our lecturer showed us, inconsistency may signal three possibilities. One, true biological change, which we should be very much interested in as scientists. Two, system-related methodological weakness. Or three, poor quality of reagents, which is a signal of test condition variability. The responsibility of the scientists, therefore, is not to ignore complexity. This was not what I was expecting, but rather to interrogate it. My fourth and final lesson comes from our lecturer's own journey. And from that, we learn the value of openness and adaptability. We heard a story from agriculture to medical microbiology, from molecular bacteriology to national surveillance systems. He reminded us that careers are not always linear. And this is important, especially for our young ones, our students who are here with us today and listening to us online. Careers are not always linear, but they can be purposeful nonetheless. See the impact that he has already made, and he still has way ahead of him. Sometimes what begins as an unexpected turn becomes the very path through which we make our most meaningful contributions. Now, after this lecture, some of us, at least I would be looking at my laboratory results more critically, maybe with a little more suspicion than before. But perhaps that was the whole point. Because if there's one thing that Prof. Dayie has taught us tonight, and it's that we must not confuse data with truth without first interrogating the systems that have produced the data. Science matters, but systems matter even more because it is systems that bring science to life. Prof. Dayie, your work reminds us that surveillance is not just technical, there are ethical considerations because it's about patient safety, public trust, and national responsibility. Distinguished guests, inaugural lectures are moments for scholars to allow us into their intellectual spaces, to give us an idea what ignites their intellectual curiosities. And our lecturer this evening has done exactly that. He's even gone beyond that. And it's been a declaration of a lifetime of intellectual commitment. That's what we have witnessed today, and he's done that so clearly, rigorously, and with purpose. He's a young man. He has many more years of professional life ahead of him. And so this is not the end. This is a declaration that he is indeed committed to what he has done these past 2 decades, and he will continue to work with his collaborators to ensure that our healthcare systems actually get improved. Tonight we have heard that when microbes speak, not through human languages though, but through signals, resistance signals. And we have no doubt that Professor Dayie is committed to contributing to ensuring systems integrity and improved healthcare systems. We have seen the University of Ghana's second strategic priority, which is impactful research, at play this evening, and we have also seen our fourth strategic priority, which is engagement and partnerships, at play, considering his contributions at the national and international levels. Professor Dayie, we celebrate you here at the University of Ghana. We honor your contributions, and we look forward to a continued impactful work. Ladies and gentlemen, please join me in congratulating our inaugural lecturer once again. So thank you and have a very good evening.
We are also thankful to you as well, our Chairperson and Vice-Chancellor. Let's appreciate the Vice-Chancellor once more. She gave us a very good summary of the lecture that we just listened to. Thank you very much, Madam Vice-Chancellor, Professor Nanaba Appiah Amfo. I would like, on behalf of the Vice-Chancellor, who extended invitation to all of you, as well as the management of the university, thank you all for joining us, both physically and virtually. I am aware that Professor Reggie Neal, Pro-Vice-Chancellor in charge of internationalization at Stellenbosch University, together with other members of Stellenbosch University community, are online with us. We are very much appreciative of your presence. And we thank you all very, very, very much. I will take a few announcements. But before I do that, let me extend appreciation to our colleagues who are doing the sign language for us. We have Mrs. Joyce Agbedaho seated right there. And right by my side is Mr. Martin Atanyamiche. They are from our Center for Disability Studies and Advocacy. Thank you very much, colleagues, for your good job. I would also like to extend appreciation to Promasidor Ghana Limited, our official beverage sponsor for our scholarly lectures. They always come to support us, and we are very much grateful. Now I'll move on to announcements. Prof. Dayie said a lot of things here, but you didn't have the opportunity to ask questions. That's the nature of inaugural lectures. He's an authority in his area, and so once he speaks, we don't ask questions. But we are kind enough to offer you a platform where you can ask questions. So prepare your questions and meet Prof. Dayie on our research and innovation agenda on Radio Universe 105.7 FM, coming Wednesday, 6th May 2026. The conversation starts at 9 a.m. Please meet Prof. Dayie there with your questions and comments and get more insight into the lecture. I'll take the date again. Wednesday, 6th May 2026 at 9 a.m. on Radio Universe 105.7 FM. You will meet our distinguished professor and lecturer there. We have some upcoming events. We will have the next inaugural lecture on 14th May 2026. 14th May 2026, here in this hall, same time, we are meeting Professor Vincent Boima, also from the University of Ghana Medical School. Distinguished ladies and gentlemen, for the 3 successive lectures, we are having all the professors from the University of Ghana Medical School. The last one was from UGMS. This one is from UGMS. The next one is also from UGMS. And we invite you all to come listen to Prof. Boima. We are going to hear him address the topic, From Genes to Mind, Holistic Pathways to Precision Kidney Care for Africa. From Genes to Mind, Holistic Pathways to Precision Kidney Care for Africa. Here at this venue, 5 p.m. on 14th May 2026. Please don't miss it. You see this announcement at the inside back cover of the brochure that you have. We also have a student experience conference coming up. We will announce the details later. So all students here, please keep in mind and look out for the announcements on our social media platforms and on the website. A student experience conference for you all to learn a lot and to experience what innovations are coming up in management relationship with students on this campus. I'll take the order of refreshments. We will have all our invited guests join the members of convocation and the platform party. On my left side, you see a setup there. That is the north wing. All our invited guests, please join them there for refreshments. And as I said earlier on, Promasidor Ghana is a official beverage sponsor, and they are here to refresh all students. So all students, you are invited to meet Promasidor Ghana at the forecourt of the Great Hall, the AA Kwapon Quadrangle, for your refreshments. At this point, distinguished ladies and gentlemen, we will rise for the university anthem, but please also take note of the order of recession. After the university anthem, the platform party will recess first, and then the rest of us will follow, and we'll do some more group photographs outside. Please, let's rise for the university anthem. You'll find the lyrics on page 12 of the brochure as well as on the screens. Please, let's remain standing as the platform party recesses.